YouTube channel. I am Prashant from Sri Venkateshwara College of Engineering, second year, fourth sem. Today I am here going to explain about introduction to sorting algorithm. Sorting is a fundamental operation in computer science where data elements are arranged in a specific order. Sorting algorithms are essential tools for optimizing data storage, retrieval and processing. This section will provide a high level overview of an importance and key concepts of algorithms. Insert sort Insertion sort. Insertion sort is a simple and efficient sorting algorithm that works by interactively building a sorted subarray from the input array. It is a comparison based algorithm that works by gradually building a sorted portion of the array by inserting elements from the unsorted portion into their correct position. Here are the steps to perform insertion sort. Start with the first element as a sorted region. Take the next element from the unsorted region and compare it with the element in the second sorted region. Insert the element into the sorted region at the current position. Repeat the process until the unsorted region is empty. The sorted region now contains the entire input list. Here an example of how insertion sort works. Suppose we have the following inputs list: 89, 45, 68, 90, 29, 34, 17. First iteration. For I is equals to 1 to 6, V is equals to 45, J is equals to 0, while 0 is greater than or equal to 0 and 89 is greater than 45. A of I j plus 1 is equals to A of j. J is equals to 0 minus 1 is equals to minus 1. Then use the while statement. While minus 1 is greater than equal to 0, A of 0 is equals to 45. Second iteration. For I is equals to 2 to 6, B is equals to 68, J is equals to 1, while J is less than equal to 0 and 89 is greater than 68. A of j plus 1 is equals to A of j. J is equals to 1 minus 1, while 0 is greater than or equal to 0 and 45 greater than 68. A of 1 is equals to 68. Then the array will be 45, 68, 89, 90, 29, 34, 17. Third iteration. For I is equals to 3 to 6, B is equals to 90, then J is equals to 2, while 2 is greater than or equal to 0 and 89 is greater than 90. A of 3 is equals to 90. Then the array will be 80, 45, 68, 89, 90, bar 29, 34, 17. Fourth iteration. For I is equals to 4 to 6, V is equals to 29, J is equals to 3, while 3 is greater than or equal to 0 and 90 is greater than 29. A of j plus 1 is equals to A of j. J is equals to 3 minus 1 is equals to 2, while 2 is greater than or equal to 0 and 89 is greater than 29. A of j plus 1 is equals to A of j. For that, A of 3 is equals to 89, J is equals to 2 minus 1 is equals to 1, while 1 is greater than or equal to 0 and 68 is greater than 29 is a true. And A of j plus 1 is equals to A of j. J is equals to 1 minus 1 is equals to 0, while 0 is greater than or equal to 0 and 45 is greater than 29. The statement is true. A of j plus 1 is equals to A of j, and j is equals to 0 minus 1 is equals to 0, while minus 1 is greater than or equal to 0. The statement is false. A of 0 is equals to 29. Sixth iteration. For I is equals to 6, V is equals to 17, J is equals to 5 are the values, while 5 is greater than or equal to 0 and 90 is greater than 17. If the test statement is true, a of j plus 1 is equals to a of j. J is equals to 5 minus 1 is equals to 4, while 4 is greater than or equal to 0 and 99 is greater than 17. If the statement is true, a of j plus 1 is equals to a of j. J is equals to 4 minus 1 is equals to 3, while j is greater than or equal to 0 and 68 is greater than 17. The statement is true, a of j plus 1 is equals to a of j. J is equals to 3 minus 1 is equals to 2, while 2 is greater than or equal to 0 and 45 is greater than 17. A of j plus 1 is equals to a of j. J is equals to 2 minus 1 is equals to 1. And while statement 1 is greater than or equal to 0 and 34 is greater than 17. If the statement is true, a of 2 is equals to 34. J is equals to 1 minus 1 is equals to 0, while 0 is greater than or equal to 0 and 29 is greater than 17. The statement is true, a of 1 is equals to 29. J is equals to 0 minus 1 is equals to minus 1, while minus 1 is greater than or equal to 0. The statement is true, then a of 0 is equals to 17. Insertion sort efficiency. Insertion sort is a simple sorting algorithm that builds the final sorted array one time at a time. Its efficiency is based on its ability to efficiently sort small arrays or partially sorted arrays. Insertion sort has a time complexity of 0 of n power 2 in the worst case scenario. Best case scenario for insertion sort. The best case time complexity for insertion sort is 0 of over n. When O of n, when the array is already sorted. In this scenario, the algorithm only compares each element with its adjacent element and moves on to the next element. This makes insertion sort highly efficient when dealing with nearly sorted arrays. And the summary. Insertion sort is a simple and efficient algorithm for small data sets or partially sorted arrays. While it may not be the most efficient for large data sets, it has its advantages in specific scenarios. Understanding the efficiency and limitations of insertion sort can help in choosing the right sorting algorithm for different tasks. Introduction. Topology sorting is a method used to order the vertices of a directed acyclic graph in a linear order. It ensures that for every directed edge from vertex u to vertex v, u comes before v in the ordering. This ordering is useful in scheduling tasks, resolving dependencies, and optimizing operations. Understanding directed acyclic graphs. A directed acyclic graph is a graph with directed edges and no cycles. In a DAG, nodes are arranged in a way that there is a consistent direction of dependencies between nodes. Topology sorting is only applicable to DAGs as it requires a linear ordering of nodes without any cycles. Depth first search algorithm overview. DFS is a recursive algorithm that explores as far as possible along each branch before backtracking. It uses a stack to keep track of nodes to visit and marks each visited node to avoid revisiting them. DFS is commonly used in graph traversal, topology sorting, and finding connected components in a graph. This is a topology sort is. DACB 0 O. Source removal method of topology sorting. In the source removal method, we repeatedly remove nodes with no incoming edges from the graph. The removed nodes from the topology order of the graph. This method is efficient for topologically sorting a DAG and can be implemented in linear time complexity. In this removes D. The topological order is D. Remove A. Topological order D and A. Remove B. Topological order D, A, B. Remove C. The topological order D, A, B, C. Remove G. The topological order D, A, B, C, G. Remove E. Topological order D, A, B, C, G, E. The topological order is D, A, B, C, G, E, F. Thanks for watching.